Okay, this next problem is actually rather easy. So I'm just going to show you the picture, and we should be able to answer this pretty quickly. Figure 220 depicts the motion of a particle moving along an x-axis with a constant acceleration. What is the magnitude and direction of the particle's acceleration? So this is really not terribly hard. What we need is one or two velocity, or sorry, we need two velocity measurements somehow, and then we need a time between them so we can calculate acceleration. So acceleration, remember, let's see, it's not quite where I want to be drawing, so let's try this. Acceleration equals change in velocity over change in time. So the first thing I want to do is let's calculate a velocity between 0 and 1 seconds. So let's say the velocity from 0 seconds to 1 second. So let me just make a little chart, tell you what. So we're going to say t equals 0 seconds, 0 seconds, x equals negative 2 meters. Okay, right equals negative 2 meters. Did I get that right? Close enough. All right. At t equals 1 second, we have x equals 0 meters. And at t equals 2 seconds, we have x equals 6 meters. So let's say the velocity between 0 and 1 seconds. Let's find our velocity. Let's do it for this point and this point first. So let's come down here. We'll say the velocity is, so we end up at 0 meters minus negative 2 over a 1 second interval, which is going to equal minus 2 meters actually. So its velocity is going to be 2 meters per second, and the time here, we're going to take the average time between these two. So we're going to say the time here equals 0.5 seconds. So we're going to say at 0.5 seconds, this all goes together, at 0.5 seconds, our velocity, gosh, I hope I'm not cutting anything off, is 2 meters per second. Similarly, when we take these two, so the second and third time measurement down here, we're going to say at the time of 1.5 seconds, and the velocity there is going to equal 6 minus 0 meters over another 1 second. So right here the velocity equals 6 meters per second at time equals 1.5 seconds. And the problem is I can just barely write on this because this stupid thing is like halfway off the page. But anyway, long story, I won't explain it. But anyway, so that's our second data point for velocity. And so now we can just take A equals change in velocity over change in time. And change in velocity was 6 minus 2 meters per second. And the change in time was 1.5 minus 0.5 seconds. And if we just bring this down a wee tiny bit, what we will get from that is 1.5 minus 0.5, so over 1 second, so is 4 meters per second over 1 second, and that's just going to give us an acceleration of, oh gosh, alright, let's see how well this works. Okay, so of acceleration equals 4 meters per second squared. Okay, so now let's try plugging this in and seeing if this gets us the answer. So this is 4 meters per second squared, and the direction, well, we were doing this in a positive direction. It says the particle is moving along the x-axis, so it's got to be positive x then, right? So let's see if I get this right. And yay, I did.